Hey everyone, welcome back to the Microsoft Security for ISV series, and Happy New Year. So we're excited to continue our second session for the series, Design Your Product with Security in Mind. So the series is tailored for ISVs, independent service vendors, although in some ways, the concepts and principles are applicable beyond ISVs. So we dive deep into the unique challenges and opportunities in securing your applications and more importantly, your customers. And in the previous episode, we cover security fundamentals for ISVs, where we went through essential strategies from building a strong cloud security baseline to adopting zero trust model and fostering a security first culture. So today we'll explore key strategies to help you design your product with security at its core. So thank you for joining us on this journey to help improve your security posture. And before we get started, let's cover the logistics really quickly. So this event offers live captions in multiple languages, and here's how you can enable them. So you can go to language and speech in your Teams, select show live captions and choose your preferred language. And for the best experience, we do recommend you use the Teams desktop client. So we'll also have a Q&A session at the end to address any questions that you may have. And in the meantime, though, please ask away your questions using the Q&A button, and we may also address them as we go along, via chats. So please do that so that we can help the session more interactive. So today's presenters are myself. My name is Vic Badana. So I'm a partner solution architect based in Melbourne, Australia. So my work focuses on helping ISVs, ISV partners build scalable AI and SaaS applications and unlock growth using the latest cloud technologies. Joining me, of course, is Dean Corcoran, with experience over many years making tech work for real people. So Dean partners with organizations building their tech strategy, working to accelerate business goals and aspirations, leveraging the latest tech. So agenda for today. So we'll cover 3 essential topics to help you design your product with security in mind. So number 1 is really about setting the stage with an overview of the Microsoft Security for ISV series. So we'll include some insights as to why and the purpose of the series and how we can empower ISVs to prioritize security throughout the product design lifecycle. And the second segment, this is where Dean will cover the unique security challenges ISVs face, from safeguarding customer data to managing regulatory compliance in a highly interconnected digital landscape. And we'll also discuss the benefits of embedding security into your product's architecture early in the dev process. And the last segment, last but not least, secure development lifecycle essentials. So this is where we'll explore practical, actionable strategies for incorporating security into every phase of your dev lifecycle. So from threat modeling and secure coding practices to continuous monitoring and incident response planning. So this segment will really equip you with the tools and knowledge needed to design secure and resilient applications. So to set the context, cyber threats have grown 5x from last year. So cybersecurity landscape is really evolving at a very high rate, and the numbers tell a really concerning story. Just to let that sink in a little bit, right? So 340 million nation-state attacks, cybercriminal happen every day. Really underscore the speed of these threats. Password attacks have grown from 4,000 to 7,000 in 2024, really showing the sheer scale of the problem. And Microsoft now tracks over 1,500 threat actors, a significant leap from 300 in 2023. So reflecting the growing, now 2025, the stats haven't come yet, but reflecting the growing sophistication of adversaries. So these trends highlight why prioritizing security is really no longer optional. So as ISVs, it's really critical to adapt and stay ahead of these challenges, because our solutions, our applications, our services are being used by many organizations. So ISVs play a huge role in this. With that in mind, so let's introduce the Security for ISV series. The era of AI has suddenly revolutionized and bring a lot of benefits. And it changes on and impacts the way ISVs operate. From enabling cutting-edge solutions, AI has been, everyone's mouth. Everyone's talking about it, including ISVs. So it unlocked a lot of opportunities for innovation. However, this progress has come with a price and complexity. So to help ISVs navigate these challenges, we're excited to introduce the ISV Security Series. So a comprehensive collection of webinars where we can provide ISVs with tools, insights, and strategies needed to enhance their security posture. And what we're going to do as well, we want to use this as a forum where we can learn and share together on security and specific challenges, lessons learned, anything related to your experiences working and securing your applications. As you can see, there are links available. So if you want to register, so go to ak.ms Asia ISV Security for upcoming sessions. If you miss the session, we record this and we upload them to our channel, to that URL recording. And then we also aim to bring, publish the blog post in writing, any actionable items or takeaways from any of these sessions. So please keep an eye on that, and we look forward to sharing and learning this together with you. So we have come up with 10 episodes in the series with the aim to capture, broad, real-world challenges for ISVs when building and securing their applications. So as you meet the increasing demand from your customers, AI presents those unique and new challenges and addressing those new threats, right? So we'll cover not only the fundamentals, but also the AI era security. So additionally, ISV work a lot with Marketplace. So we aim to bring important aspects from a security perspective when you publish your solutions with our commercial Marketplace. So you can find more info soon as well on our landing page, as well as a blog in our blog as well. So please keep an eye on that as well. I'd like to also introduce you to the team behind this initiative. So without this team, it is impossible for us to launch this series. So everyone in this screen plays a pivotal role in the launch of the series. So really appreciate and thank everyone in the team that supports this initiative. And without further ado, I'll hand over to Dean, where he will cover the topic for today, which is design your product with security in mind. Go ahead, Dean.
Great, thank you very much, Vic. Look, it's security is a very important topic, so it's great that we're running this series to help you design your next product with security in mind. We've already done a number of high-level sort of foundational parts or discussions on security, and today we're going to get a bit deeper into the things to think about when you're thinking about security with respect to the design of your product. At Microsoft, security is the number one priority. Microsoft is subject to probably some of the largest attacks. We have some of the biggest attack surface due to the scale of Microsoft operations, the number of different products and services that we have. And security needs to be the number one consideration, whether it be Xbox, Microsoft Teams, Microsoft 365, physical products like Microsoft Surface, Azure, Windows, and anything else that might be. And so Microsoft Cloud, it runs on Azure, it runs on security. If we're looking at some statistics, according to a fairly recent survey of over 600 organizations, only 5% of companies avoided web attacks in production. In other words, their production systems, the services that they're offering and their customers using every day, when they were subjected to an attack, only 5% of them, 1 in 20, was able to avoid that web-based attack in that production environment. And when we look at the scale and scope of attacks that we see across the globe today, and all the different places that they can be coming from and the different techniques that they use, it's really important for your organization to start thinking about that. And, Microsoft's no exception when it comes to being subjected to these attacks. And if we just take a couple as examples of the types of changes in the way that attacks are occurring, if we look at SolarWinds as an application that many organizations, including Microsoft, use to manage infrastructure, it had code within it which had compromises built in due to the supply chain, or the code chain, if you will, having that vulnerable code within it. and that impacted over 18,000 individual customers. CodeCov, it was a breach of vulnerable developer secrets. So secrets, passwords, codes that are used to access systems were sitting within the code themselves. And also Log4j, we saw vulnerable source code that was used by many different organizations that had vulnerabilities in it. And so therefore, wherever that code was used, those organizations were exposed to that attack. And so we're seeing, once upon a time, it was all about the perimeter and making sure your network security was resilient and making sure that the threat actor just couldn't get through your firewall, through that secure boundary. Today, what we're seeing is that the attack actually, it might start from the outside in very early days in that Trojan horse style within code that is then implicitly trusted by organizations and then moved into the organization and then put into production systems. What we're seeing is, 1.5 million, over 1.5 million cloud threats a day. With the global economy and the global supply chain, the increased dependence on using connected technologies such as the internet in order to do business and keep business running, whether it be commerce or whether it be products and services or whether it be providing safety and communications, it's very important that we understand that these great networks that we have, that we can do a lot more than we used to do and open up a lot more possibilities and accessibility in making our lives a lot better, also open up an increased attack surface from threat actors. There's been massive surge, I should say, in denial of service attacks, distributed denial of service attacks. The attack patterns are shifting continually, and we could go into the specifics of how they're changing and how organizations are trying to take control of people's accounts and things like that. But the real thing to note here is that it is changing all the time. And so what we knew in the past about security is not necessarily going to get us through tomorrow in protecting our organization and our technology that we use in your applications. The very nature of us having this sort of hybrid world where people may be using a phone to access your services today or accessing your product today, tomorrow they're using the web, another day there might be an internal application, or another day they might be accessing indirectly via an API, via another third-party application in a business-to-business scenario, is that the complexity of applications today is more than just running on a given single operating system and ensuring that the code that's running on the operating system is safe in that one location. They're inherently online and subjected to attacks from the device through to the network connectivity, through to the actual individual themselves and other avenues. And so you have to really secure across everything. This isn't about just network security or knowing what malicious code or viruses might be out there, or the different social engineering techniques. It's everything. You have to think about it in every layer. And so there's all these new types of attacks that we're seeing all the time. Also, we have this problem in many organizations, especially in enterprise, nothing gets retired. We've got this data debt, if you will, or this data swamp that just keeps accumulating. And some of that data may be more accessible than it ever was due to the needs of an organization. Attackers have heaps of options. They have lots of time. Generally, attackers have more resources than you. That's something that I need you to really understand, is that attackers have all day to be very focused about their attacks. And with you, your job, security might be just part of the job. Their job is 100% of the time, if you want to call it a job, their task is 100% of the time to focus and to find compromises and find weak spots where they can get in and get access and compromise your organization for whatever gain. The other thing that you need to be concerned with, even if you're not subjected to an attack, is just that the bar is raising around organizations' responsibilities and regulations associated with enforcing those responsibilities. And so this isn't just a case of you can be sort of ignorant. In some cases, you can't actually perform business unless you adhere to those particular standards. There's also so many different security tools out there that you need, that you're dealing with, that may propose to help solve the challenge. Now, what we're really talking about today is looking at security from a design lens, specifically from the point of view early in your product development cycle, thinking about every new feature that's coming along or the product holistically that you're designing, what are the different threat vectors that the design of your application may be subjected to, and therefore what changes to the design you can make to implicitly make it more secure. And what we find is this impact of shifting security left reduces the cost of a potential compromise substantially. It's many, many, many orders of magnitude, as you can see on this slide. So doing things very, very early in the development stages from a security point of view, thinking about secure design principles means you're not having to rework the whole design for new security methodology for a security methodology that was best practice. And so there are definite financial gains to doing this. This also includes Microsoft. Microsoft has a Secure Future initiative. Microsoft, as mentioned, is subjected to attacks daily. Right at this very moment, there is an attack, no doubt, going on that is focused on Microsoft infrastructure, on Microsoft code bases, or code that Microsoft uses within our development cycles. All the authentication systems we use, all the employees. So as a result, the three key principles that all Microsoft employees live by today is that what you do and build must be secure by design. It has to be secure by default. It's by default out of box situation. And in our very operations in a day-to-day basis, even when Vic and I are conducting this meeting today, we think about the security ramifications of those processes. And this then helps to uplift organizations that are using Microsoft products and services. Keeping in mind, in any cloud environment, in any situation where you're using other vendors' products and services, or you're using shared set of code bases or code and libraries that come from other locations, you've got this shared responsibility model. And this goes back to many concepts some people may be quite familiar with when you're starting to embrace cloud for the first time. And so make sure you understand the responsibility of whose responsibility is to build security into the design of the application or service that you're using, whether it be a SaaS product, whether it be a PaaS product, an IaaS product, or on premises. Naturally, on premises, the responsibility is pretty much 100% down to your configuration, control, and implementation. Whereas when you're using a software as a service product, which maybe that's actually what you're building, in this case, the user of the application is probably less as responsible for the secure design and implementation and deployment, and you are. And so we're sort of looking at this in an inverse point of view, and this from this perspective, where typically you're looking at it from the point of view of the user. At Microsoft, we embrace the security development lifecycle. The security development lifecycle is something that Microsoft's been using, is well published across Microsoft documentation and libraries that you can access today, and has been a long time in the making. Is continually evolving, and it goes right back to that perfect storm in the early days of people becoming connected to the internet and Microsoft realizing that security landscape was changing back then, which took Microsoft on a path of thinking about security as the top priority in the very early days. And so now moving on to 2024, we have seen security and vulnerability and really that threat landscape and security responsibility change substantially. So who should use the security development lifecycle? Look, generally, you look at it from the perspective of what are your requirements and what are your non-security compliance requirements, and how does that all come together as your security compliance requirements. This gives you that point of view of why you should be using the security development lifecycle from the point of view of your users, the responsibility to your organization and its ongoing operations, and the ability and your responsibilities also to the communities and government or other regulation that might be out there. Excuse me. Security development lifecycle encompasses everything from the design and code right through to building, then deploying, and then looking at where it's going to be deployed and where it's going to be run from. And at each particular phase of the security development lifecycle, there's these different gates. Many people might be familiar with the different gates or the different layering of the different safety mechanisms that are used in different industries, such as aviation, to try and to ensure that the aviation industry is an industry that people can trust to be using for day-to-day transport, so people can rely on planes every day knowing that there's not a safety risk. And as a result, aviation and flying today is one of the safest methods of transport, definitely much safer than the intuitive safety that people believe they get from driving a car every day. So it's actually safer to use a plane to go to the other side of the world than it is to go to the shops in your vehicle, as a result of using a development process that's very similar to this security development lifecycle practices, where we have these gates at every particular phase that look back and say, let's ensure that we've covered every potential gap as far as security is concerned. The underlying principle is that of zero trust. And that is at every layer, we look at it from the perspective of what if there's a compromise in this particular area? We should not trust that component. We should not trust that user. We should not trust that piece of code. We should not trust that network. We should not trust that hardware. And so using those principles, you can think of the device the person's using, the user in their given situation, the code that you've used, the process that you're going through, the network that you're connected to, the location that people are in order to design a much more secure product. So as we break through some of the design elements in a little bit sort of more detail from a thinking point of view, as you're going through your design in a little bit more of a piecemeal point of view, let's have a look at things to consider. The security consideration and private issue, we've got to consider security and privacy issues very importantly. So understand the risks associated with security issues. So when we say security, what are the risks? What's going to happen if there is a security compromise in a given piece of this product that you're developing, whether it be the UI, whether it be a database connection or otherwise? What is the risk of a compromise taking place, and what's the end effect of that? Could be financial, could be data loss, could be IP loss, could it be something else? Then identify and fix the security bugs during development. So if you see any bugs, security design optimizations, make sure you do that at the development phase. And apply established level of security and privacy throughout the entire process. So have a security rigor, have that sort of question that says at every stage of design, what are the security and privacy implications of the data in this given situation, or what are the possible compromises that happen at any given phase. Then ask security questions. Does my application, does it contain sensitive data? What type of data is that? Is it personally identifiable information? Is it financial information? Is it healthcare information? Is it regulatory information? Is it IP? Is it another customer's information? Does it have some sort of mechanism or some sort of a policy, a government policy or otherwise, that you need to adhere to for the handling of that type of data? If you're collecting and storing data that requires industry standard adherence requirements, then make sure you understand exactly what they say about where that data can go, maybe geopolitically, or where it can be stored, and your obligations. Make sure you also really ask whether or not you even need to be keeping that data for the function of your business or your product or service. As you're asking questions, where is the data going to be stored? Is it going to be stored somewhere temporarily? Is it going to be stored in caches? Is it going to be in a browser cache? Is it going to be stored in an application cache? Is it going to be stored on a phone or a portable device? Is it going to be stored in a third-party data center? Is it going to be stored in a hyperscale data center like Azure? Is access to the application going to be open to the public, or are aspects of your application or business or product going to be accessible to the public somewhere? Does it provide a public view? How do you understand? Do you understand the security model as you design? Sorry, identity model, I should say. Do you understand the identity model before you begin designing? So how are people going to authenticate? How are they going to prove who they are? How are they going to then become compartmentalized from other users or other pieces of data? Think about what the application is used for as well from an industry lens. Is it transferring money? Is it unlocking doors and doing things in the physical world that could be considered tangible sorts of compromises? Does your application involve working with sensitive equipment or sensitive substances such as medicine or those that are volatile or have some sort of risk associated with them, and therefore an obligation to handle it? Does the application perform risky software activities? Does it allow them to upload new content you don't necessarily have control of the source of, or download data from it as well? And so thinking about all these vectors start to open up a rigorous sort of thinking process around the security implications, I should say. So a good tip is to go and have a look at the Open Worldwide Application Security Project, or OWASP, Top 10. And there's a lot of other tips around security design for applications at OWASP. The top 10 go through a lot of the typical compromises and a lot of the typical security concerns, whether they be known vulnerabilities or otherwise, across the software development lifecycle. And so even as just an education process to see different ways that security design can affect the surface area of your application or product or service when it comes to security. Okay, so let's have a bit of a look at the overall design and the different things to think about. Microsoft follows a zero trust security strategy across all Microsoft products and services. And so from that point of view, we look at everything from a point of view of not trusting the user, not trusting the administrator, not trusting the given application component, to the level at which we ensure that it helps to limit the security profile. That involves looking at the actual coding libraries. Now, it's really common today for people to be not reinventing the wheel. Of course, you want to use libraries that other people have built, best-in-class ways of going about performing certain common functions within your software. And so ensure that you are using secure coding libraries with your software and a software framework that supports and implements security practices. So use that library that has embedded security. Make sure it has proven features that support security type operations, such as encryption, input sanitation, output encoding, obfuscation, and other security controls around the level of access and data. Don't develop security controls from scratch yourself. Make no mistake, this is definitely an area where you want people to be working from the point of view of deep security knowledge. Use always the latest version of your framework. Generally, the top line things that get fixed in frameworks are the security features. It's constantly evolving the types of threat landscape that we have. And so as a result, our code frameworks are evolving to meet that challenge. And use services for your architectural components that feature security configuration as well, your ability to slide left or right the level of security for the amount of usability versus security. Naturally, keep updating your components continually. Always understand all the different components that go into your application. Have a good inventory of the different libraries that you're using and where they're coming from, so that you can understand and keep them up to date with the latest versions of the code that hopefully have all the vulnerabilities patched. Use threat modeling as well. And so by performing threat modeling, it takes you through a fairly non-technical process of looking at all the different ways that a compromise could present itself across your application design. And so threat modeling goes through, validating your design, diagramming your design, looking at identity in the design, and then identifying the challenges and then mitigating those challenges. There's a threat modeling tool that you can download to play with your application design. It's designed to be fairly user-friendly. And the idea is that you draw out the logical flows of your design of your application and then think of the different compromises or the different threat vectors that could present. And so it's a good place to start as you start to build out how your application will work. Complete an attack surface analysis. This is somewhere where you may even get third parties involved to really test the security, test your application's resilience to find all those holes and start patching them. This is actually something you should do quite frequently, even during production. But in the design phase, as we've said previously, it's easier to fix things in the design. And so if you perform your attack surface analysis early, then it helps you to get ahead of those challenges. Then, of course, reduce your attack surface, plug the holes, use more secure code, use more secure code techniques. Go through, look at how your support code is running as well. Look at virtual machines that close down machines that you aren't using. Like, you need to be very holistic. It's not just application in its end state you should be testing. It's ensuring that the application, even its build state, is continuing to build on a foundation of security. Make sure that you know that those things that you're not using, they don't go through to production and are segregated as well. Adopt a policy of identity as your primary security perimeter. So, who is using the application? Is an authenticated, trusted customer or administrator or someone that you're expecting to use it? Naturally, the threat individuals, if you will, that are out there are not the ones that you want to be involved in your business. And so look at that from the perspective of, do you know who this individual is? Is the individual, as they're presenting themselves to the application, is it actually them? How are you going to use innovative ways to prove that who the individual says they are is who they are, and it can't be anybody else? And so common things today, and look, some of the, over 90%, last time I looked at some of the compromises we see across the Microsoft partner network, over 90% of those compromises could have been prevented by just turning on multi-factor authentication. And so do this with your users as well. So use strong authentication, authorization, platforms and patterns, and apply principle of least privilege. So even when a user gets access, only give them what they need, bare minimum, for the use, especially when it comes to risky activities that are of a higher, have a higher implication or higher sort of consequence if it isn't actually the individual performing the action. So just-in-time access helps a heck of a lot with that, and so that people only have access to what they need at the given moment in time. For example, with some banks, they implement a mechanism of a window for you to perform certain transactions that might be considered higher risk or of higher consequence. And so you normally have a transaction limit that's much lower most of the time, but then when you know that you're going to need that extra time, you're going to have a window where you're going to be performing a larger transaction, they can open up and then close that window. So it's not always just about authentication of technical things. It's actually down to the actual user flow as well. Require re-authentication for those important transactions. It's not uncommon for people to look at ways to hijack existing authentication mechanisms. And so someone's already they're in the browser, they're in your application, they're in the app, and they're using it right now. If someone's already in there, you've made sure the door is quite resilient to attack, but then how can someone compromise someone who's already opened the door and they're using your application? And so this is where just in time and looking at important types of activities that customers are using from the perspective of a security lens, and then saying, okay, in this instance, how do we maybe increase the level of security whilst not compromising the usability too much for the user that they find it quite hard? And so that's where you do see, in this instance, those sort of, those text messages or whichever that may go out to prove that person who they say they are. But of course, ensuring that you're aware that could be something that the attacker is expecting to see as well. And so I saw quite a good one recently that I put as a bit of an example, a faux example in this case, into the slide there. Not only does it say, here's your code, but it's reminding them that if anyone's asking them for this, that is not what expected. That looks like malicious behavior. And so, maximize that authentication security capability. Use my MFA. Here's that stat. Up to 90% of cyber attacks can be prevented using multi-factor authentication. Identity management. Use a good identity management platform. Naturally, something like Entra. It helps you to, it's got tried and tested techniques built in that include all those safety mechanisms that we consider around identity management and authentication, regardless of the application style. Looking at your codes and secrets, like make sure you use a key management solution for credentials and other secrets. It's very common. Even Microsoft has been guilty of compromises as a result of people who have been developing their code, but developing applications, accidentally putting secrets into the code, and then accidentally publishing those secrets out to GitHub repositories. And so those are the sorts of things that should be caught these days. Microsoft's raising the bar to ensure that when we're working in our applications that we've got intelligence that can even see if the code contains secrets in the first place. But some of the best thing to do is use a platform that doesn't require key management to be in the code in the first place. In any text form, have the key management outside of the code. Use a key management solution like Azure Key Vault, which has a lot of compliance built into it to help raise the bar on security for you. When it comes to data, of course, if you know that you're working with quite sensitive data, financial data, personal identifiable information, any information that might be considered risky or subject to increased levels of attack, then we really need to raise the bar on how that data is treated, both when it's at rest and when it's actually being transported or transferred or in transit. Use encryption. Don't hard code secrets, as we said before, and ensure that access controls are already in place for every layer of how people access their data, whether it be the backups, whether it be in caching mechanisms and otherwise. Azure has built-in encryption capabilities for at rest, in transit, and in use, and this is increasingly sophisticated. It's worth looking at the different technology that Azure uses that you can use within your application, at least even from an education point of view. Also, it's not just about the data when it's being transferred or when it's at rest. It's also while you're processing the data. And so we have confidential computing capabilities and ways to even perform calculations on data, any sort of logic on sensitive data, in a way that not even deep level access to physical infrastructure can compromise or reveal what's inside that data. So, confidential computing at Azure is in many different levels of different services, whether it be database services, whether it be containers or compute services and virtual machines. And it's a very, very varied, both from the hardware right up to the software level and the networking in between. The different features exist. Make sure your application has important file-safe mechanisms built in. So if things do go wrong, how do you trace back the source and work out how to rewind time, so to speak, to work out what occurred and potentially get things back up and running? Quite often, getting operations back up and running is the first order. How do you get the system back up and running? How do you then recover the data? And a good trail of error logging and logs that help you to understand what's going on. Both helps you in the ongoing understanding of the behaviors of your application to look for anomalies in real-time behavior, but also that behavior could actually be malicious in nature as well, but also in rewinding time, so to speak, to help you get back to an operational state as quick as possible. Naturally, logs themselves could be subject to compromise, and so these fail-safe mechanisms as well need to have a security lens placed above them. And so only log what you need, what you need to be able to do the job. Take advantage of the error and exception handling within your code. Quite often, threat actors look for ways to compromise the application or make the application behave in a way that it doesn't normally or isn't expected to. Looking at vulnerabilities in code from the point of view of just bugs, things that might cause buffer overflows or things that might make the application store data in a place where it normally wouldn't, or behave in a way that makes it easier to authenticate. Those sorts of unexpected or unintended behaviors are the sorts of things you should be capturing all the time. So understand at every sort of layer of the application what is the expected behavior of that part of the application, and then implement your try-catch blocks and other types of error handling and exception handling, or determine the terms of exceptions and error handling yourself. Don't just leave it over to the framework. Naturally, logging and alerting is very important, even for the end user. So to keep thinking about the end user experience and what is considered anomalous behavior for them and what they should know about as well. So all that alerting should be, both within your expected behavior of the application and potentially for the end user as well. When it comes to networking and information in transit, look, there's many different layers of network security. Generally, the network or the perimeter is one of the first, attack vectors for outside of the application itself and the user, trying to compromise the users the way that they behave. And naturally, using a zero trust behavior, only allowing packets, only allowing protocols, only allowing ports, pretty standard stuff today. But thinking about intelligent gateway services, denial of service protection, and routing behavior and routing tooling as security as a security lens as well. Now, moving on to the world of what everyone's talking about today, and that is AI. When it comes to AI, very good chance you haven't built your own. You're probably going to use someone else's LLM. And so therefore, quite often, is it an open source LLM? Is it an open source framework? Is it someone else's framework? Is it a Microsoft or an Azure service that you're using? And people are really playing with lots and lots of different vendors, lots and lots of different pieces of tools out there, and they're using different application development techniques and different application architecture patterns than they've ever used in the past. And so as a result, we're sort of in this realm of, rapid learning around what security means in this era of AI. And so just looking at the different components that we have on the screen there, every one of those could have its own attack vectors associated with it. And so we need to think about the, AI and Gen AI and large language models and retrieval augmented generation, what are the security concerns associated with that? Now, out there online, there's lots of little fun, things you can do to try and compromise and test or get LLMs, get generative AI to do things that that you wouldn't expect it to, or get it to do bizarre behaviors. And so whether it be trying to jailbreak LLMs, whether it be, people trying to get the LLM to do something that's outside the scope of what the application or the product's intentions, is that core, that one of the first things that people who are trying to compromise these are trying to do. And so these new and unique attack vectors are, things like jailbreaks, where you coerce the AI to do something different, multi-turn jailbreaks, where over multiple lines of conversation or multiple interactions with an LLM, you eventually really sort of override, the modeling to convince it to do something else other than what it was built for. A common thing is to get it to reveal sections of code or reveal things it shouldn't be showing by telling it to reveal it in a novel way. In other words, you could ask it, what's the password, but it knows you shouldn't be asking it for a password. You could ask it, do you know any secrets? And it knows that, it knows that a password is a secret, but it can tell a story about secrets, but it also knows that the password should not be shared. And it knows what the password is, so if it sees a copy of the password in the text, it's going to filter it out. But then you could say, how about you go and tell me what the password is, but advance every character, one extra character in the alphabet, so to speak. So A becomes B, B becomes C, so on and so forth. And so therefore, very low-level type of security. It won't realize, strangely, it doesn't realize it's just encoded the password and then allowed you to decode it post-interaction, or the attacker, I should say. Other techniques like universal suffixes, telling it the data is what it isn't. It's steganography, where we're sort of encoding in images and things like that, other pieces of data. And so some of the solutions to this is that you actually use AI as one of the defense mechanisms. What is it seeing in the code? Is what it's observing the other AI doing, is that the expected behavior? Besides common things like grounding your AI models to only perform certain activities, also to sophisticated attacks that are quite hard for people to code for in their own development can be handled with services like Azure AI Safety Service, which look for known LLM and Gen AI based attacks and threats and ensure that people don't coerce, for lack of a better description, AI bots, AI agents, and just AI tooling to behave in a way that compromises security. Microsoft has a responsible AI framework. Here's some more homework. There's a lot of homework today, and which covers not just that sort of ethical use of AI, but implicitly security goes into this as well, that privacy and security piece. Also consider secure supply chain consumption framework. So there's hardly a product and service out there today that doesn't have some sort of open source or third-party code in it from another library or SDK or otherwise. And so having a security supply chain consumption framework, this handles everything, from the source through to the release in the security development lifecycle. It looks at it holistically. And what we do typically is we classify organizations and how they implement the security supply chain consumption framework into one of four categories, whether or not they're just doing sort of basic minimum open source governance right through to advanced threat defense, where every person and every body is an advocate and open, and looking for security and compromise, and you've got advanced telemetry and detection mechanisms in place and alerting and response mechanisms. It generally covers three core concepts and then three goals. And so I won't go into much more detail other than leave that one as some homework for you, just so we can keep on time today. We can implement some of this using the GitHub. You can use the GitHub DevSecOps frameworks and principles to look at how you can work with the secure supply chain frameworks and to incorporate it as part of your whole development lifecycle, from your supply chain to your code through to your own development practices as well, and shift that DevSecOps into your process. Here's an example of that software supply chain output from GitHub Advanced Security, and it shows you where your risk is, where your code scanning is, and secret scanning, so that it's easy for us as humans to sort of slip up sometimes and take an easier path rather than a secure path. Also, there's other vendors out there that provide some good dashboarding for this as well. If you look at men.io as an example of that security supply chain. Other tooling you can use as we sort of look at those other new performing and designing, looking at the reality is, back to the start, threat actors have more time, they have more resources, and have that single purpose. Whereas chances are, you as someone who's building a product are really, you're juggling more than one role. And so that's where using tools like Microsoft Defender and Defender for Cloud help you to see security compromises and patterns that are anomalous that may constitute a security compromise or risk taking place, or something that's leading up to, so that you can have eyes in all places at once. And Defender for Cloud is particularly good for that because it provides that advanced analytics, that advanced sort of inspection at a whole architecture level, at every service level, so that it can see what might amount to everything from a distributed denial of service attack right through to anomalous behaviors that might be leading to some sort of data compromise, data patterns and data flow patterns that don't look like normal operational cycles. Copilot for security. So when you are talking to your security products about security compromises, whether they're happening right now or whether or not you're trying to improve it, this is where it's going. Again, you don't have every moment and every day to ever understand the nuances of security, of way compromises take place. Some of it can be inherently extremely technical and very, very covert and nuanced. And so unless your day job is security in every, not only security across the board, but security in a given specific area, and that is your one job 24/7, it's very, very hard. And so Copilot Security gives you that AI interface and that much more friendly way of working with security products. And that advantage is, there's continual development going in. It's a major priority for Microsoft, obviously, to ensure that Microsoft customers are secure and they have productive businesses. Look, as I just finish up, that's been a lot. And I must say, I'll be honest, Vic, I'm getting a bit tired. So a few last concepts. I'd like to leave you with some concepts because it's a bit of a dump, those last slides, lots of slides, lots there. It was hard to go through and chuck things out today because it's quite an important topic. And so hopefully you can go back and review this in the recording. But it's good to have you see. But look, here's some framework. I like to think in concepts and think in principles that are simple to remember, but then easy to apply generally as you're going about your job on a day-to-day basis. And this is an oldie but a goodie, if you like that framing. CIA, confidentiality, integrity, and availability. So think about everything you're doing, whether it be a process that you're performing operationally, or whether it be the code that you're developing, or whether it be the service that you're intending on using from the point of view of how does it maintain confidentiality for my users? How does it maintain confidentiality for my organization? How does it maintain confidentiality for the running operations and data? How does that what I'm doing or the product and service that I'm using impact, or how can we configure the integrity of that? How highly available is it? Can we make it more highly available? Can it stay? I've gone to availability more than integrity. How resilient can it be? Can it maintain a level of security, or a level of obfuscation, or a level of protection of the system? And then availability. How well can we ensure that operations continue and the business does not fall over very easily? Can it stay online? Can we recover from a compromise? It will happen. The application will fall down. One day it will stop working. Absolutely guaranteed. One day your app will crash. There will be a compromise. Someone's attacking it now, and it will happen. How quickly can you make it back available again? How quickly can you get to your root cause analysis? So, what are you doing right now? How does that implicate the CIA and overall information security from the point of view of your customers, users, organizations, communities, your application provider, your staff, your technology, and the vendors and platforms that you're using? Zero Trust Architecture is a good place to look as well. Have a look online for Microsoft Zero Trust Architecture. Microsoft Zero Trust Architecture also shows the different Microsoft products that there to help with that if you choose to use them. And I'm not here to really look at those today. I'm here to sort of give you that framework and at least that foresight to just start thinking with the secure practices in mind. At Microsoft, it's all about zero trust. We've got the security adoption framework you can go and look at. Look at the cloud adoption framework, and then there's security framework applications as well. Microsoft Secure Future Initiative is a Microsoft thing that we're building as a layer that you can just depend on. That's the way Microsoft is operating today. How do you do security? Zero trust. What is Microsoft doing? We're forming the Secure Future Initiative for everybody, for all organizations and people that use our products and services. And how do we implement it? You use a secure adoption framework. And with that, lots and lots and lots of extra reading to do. There's your homework. Go and have some fun with that. That's a bit of a boom. I dropped the mic. And I'm going to pass back to Vic.
Thank you, Dean. Appreciate it. Thank you, everyone, for attending the session. Thanks for the content and all the various wisdom and all the links that we paste in as well in the chat. So please feel free if you have any questions, if you have anything that you'd like to share as well. We'd love to hear from you. I know that this is currently public holiday in certain region, so we know that there's not, I guess probably not. We need to pick a better day for the next session. And apologies as well. We ran over time as well, so we'll probably update the next session. Probably going to be a bit longer so that we can capture the session as well as the presentation and Q&A. So I don't receive any questions. So what I'll do, I might just have a chat with you, Dean, just quickly, so that we can make it as interactive as we can, right? So I guess from your, I guess you work with a lot of companies, organizations, partners, and so on, and you probably saw that security usually is being put, usually at the last stage of any kind of product development or development life cycle. People try to tap in security as part of I remember before I pushed out a product, and then you go through some security audits or security sort of gating process to make sure that you're compliant. And by that time, you realize that, hey, you've made some decisions that affect the kind of the design of your product, and therefore you're going to need to go back, and the costs were pretty exponential in terms of kind of getting that fixed and embedded into your product. So I just have a quick thought and in my mind, and knowing that recently, anyone heard of DeepSeek? Sorry, DeepSeek, 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 and
Deep snake.
it's just
Is
been
that something to do with Lunar New Year?
yeah, there you go. DeepSeek, and as you know, this was brand new, like literally like days, and not even a week, and we were able to kind of push that out and make that available as a model as a service now. And I believe in my thinking is that if you embed your security well into your practices, security shouldn't impede, but it should be it should accelerate the product development and ability for you to push out features, because there's a lot of some security concerns around ability for you to use the model and so on in a hosted model. But obviously Azure comes with a lot of the compliance and trust, and everyone knows and very comfortable with the way we operate. So I just want to hear your thoughts. How do you usually pitch your partners, organizations, etc., on convincing that, hey, you should actually invest in security from the get-go?
I think it's a bit like a foundation, right? My view is, look, when I was first learning the code many years ago, I don't really code much anymore, more just to sort of understand how some of these things work and how you can break them. But I think when I first sort of went to university, I was learning to code. No one really thought about security. It was just all about data types and just getting things running, right? But then when I was starting to learn new coding frameworks, I realized that people were starting to think about security, especially when you're starting to build web applications. They're starting to think about security, and some of that security stuff wasn't so much security as it was just good design that had a security implication. And it was very hard to unwind if you went down the wrong path initially. And I remember one of them was for, I think it was LAMP server stuff. Anyone remember sort of Linux, Apache, MySQL, and PHP? One of them was if you put you put your files that are going to be serving the web pages in one location, but then there's the code that your files are actually, or the code that's actually running underneath. You put it in another location so someone can't accidentally type the path to some of your source code and have that appear in the browser. And so it was a very, very simple thinking that was actually quite hard to unwind if you went down a path of putting your, like, for example, your images and media and everything in exactly the same folder, so to speak, as your code base. Then moving those apart was actually something that was harder to unwind afterwards. And so it was very simple framing. And so, look, it's a foundational thing. If you build a building on pretty bad foundations, it's really, 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 really hard. Like, it's a bit of a metaphor, but there's a lot in what you just asked. There's a heck of a lot in trying to put a new foundation under an existing structure. It's nearly easier to rebuild again in many instances. And it doesn't, that is not mutually exclusive from bad sort of security product design, technology design and software design, really. You mentioned, interestingly, LLMs, right? It takes a long time to go and build an LLM, and I won't go down the deep sea sort of path too far here. But if you don't want certain information to come to be answered from an LLM, but it is inside the LLM, you've literally got months to rebuild that LLM, and it can be quite hard to put layers around that. You can see there's interesting stuff going on the internet right now where people are trying to get an LLM to talk about controversial topics with regard to that particular LLM. And depending on how they approach it, they're able to get it to do things that they don't want it that DeepSeek doesn't want it to do. And so it just shows actually how hard it is to unwind something like that. Now, that's an extreme sort of example, but it's a perfect example of if you build, in that case, they're building off someone else's foundation. And so every time you're adding that extra layer, you're adding that extra layer of complexity and implicit design culture and design ethic into your application. And so you need to be working with, trusted supply chain, trusted service providers. That's why it's good that, we've got advanced modeling in Azure and you've got everything there, because we add not only a layer of defense from a foundational, but also the add-on security defenses afterwards. And so look, there's a fair bit in that. Look, I know I've gone down paths with building stuff in the past where you're like, you're halfway through and you're like, oh dear, this is actually quite constant. And I think a lot of people, even if it's got nothing to do with security, you know how hard it can be to reverse. But if you're thinking about that very early, that's the point of this design today, is if you're thinking about it up front and you're always going to have edge cases where there's something new, it's easier to fix that edge case that's something new than foundational stuff that you should have just got right in the first place based off current best practice and themes. So
brilliant. Yeah, thank you for that. Really appreciate that, Dean. And just a bit of a teaser as well for the next session. We have build how you secure your multi-tenant identity. So that would be awesome topic. And that's identities. Perimeter. You mentioned that it's a perimeter in the cloud world, in the new era of AI as well. So I think that session not to be missed. So if you haven't registered, please do. We're going to use the same link for that. We'll be also going to be inviting our product manager as well in that, so to be able to give you a bit more kind of relevant information on the tooling aspect as well. Alrighty, thank you so much, Dean. Really appreciate your time and the effort you put in on the presentation, and everyone else. Thank you very much for attending.
Thanks all.
Thank you all.